Well, hey, Math 8, and welcome to 511. This is Monday's notes page. Just letting you guys know, once again, if you haven't read the announcement, the rest of the year has been posted. So you guys obviously don't rush through it, do quality work, but the rest of the year is posted. As soon as you finish this, you are done for eighth grade math. So that's exciting. But let's go ahead and talk through here this notes page. So first of all, the assignment, just kind of note this one fact here that you only have one attempt. So be sure to review these notes as you're working on them. Make sure you do high quality work on that very first attempt. If you have questions, once again, you don't have to submit it. Just right away, you can email me and say, hey, Mr. Erickson, I'm stuck with number 7. Or you can hop on during Zoom, and get some help and just kind of check your answer with me. So just make sure just so you see here, you only have one attempt. So make sure to use that wisely. So just kind of a heads up on that. And then this once again is due next Monday at 8:30. So just make sure you see that as well. Just because I have the rest of the year posted doesn't mean it's all just due on the 22nd or whatever. So this is still due by next Monday. So make sure you do this here this week. So beyond that, here's just kind of the notes here, just basically looking at our different types of graph and deciding, well, which type of graph would be best for maybe this data that I'm looking at. Obviously, the different types of graphs have their strengths and their weaknesses. And so we want to kind of be familiar with those and be able to kind of make an educated decision on, hey, this type of data, a bar graph would be best, or this type of graph, a circle graph would be best. I'm realizing that I think on a couple of these, there might be more than one right answer, but I think it'll kind of give you a little bit of info on that as you go through the questions. But let's look at them. So bar graph, when to use that? When the data shows how many are in each category. Okay, the must-haves, the data must show the frequency or how many occur in each category, right? So we need to know, all right, 5 people like dogs, 4 people like cats, something like that. The line graph, notice the key here, the data involves time. How does something change with regards to time? Okay, none of the other data, really, all the other graphs don't deal with time. So this one really is a giveaway if you can just focus on seeing, does it deal with how something changes over time or does it not? I'm looking here at this first one. Example 1, just jumping ahead here, and I'm noticing right away, look, there's a year column, right? The year 2014, here's the company profits. The year 2015, here's the company profits. They went down a little bit, right? So you see how it changes by each year that goes by. So I know right away, without even looking at much more than that, then the example 1 is the best choice here is going to be a line graph, right? Because it involves how it changes over time. So that must show time. All right, circle graph would be the data shows how many are in each category. So it can be easily converted to percents or parts of the whole. So once again, maybe I want to know 50% of people prefer dogs, and the other 50% of people prefer cats or something, right? But you know the percentage, how the part compares to the whole. And so that's kind of a little bit different than the bar graph, right? The bar graph was kind of comparing, all right, how many people said cats versus dogs. But maybe the circle graph says, all right, well, this percent like cats, this percent likes dogs, maybe this percent likes hamsters, well, whatever. So of the whole. Okay. All right. Histogram then would be there's a lot of categories with numerical data. So maybe you've got just like a ton of different, you've got like a ton of pieces of data, right? Too much to put just in like a bar graph or a circle graph. That you need to split them up into classes, right? Or into groups or into intervals, where that's what would be the idea of a histogram. And so once again, the bar graph would not be appropriate because there's way too many categories, right? There's way too many pieces of data. It's typically more numeric data too. You're not going to see just how many like dogs and cats. You're going to see probably housing prices in the state of California in different cities or something. It's going to be kind of more probably numerical or just numbers type of data than just what's our favorite animal kind of thing. So that's kind of a little bit there. There's obviously more to read there. But that's kind of the big thing, right? So large amounts of numerical data. Remember, the categories aren't as important. It's more about kind of dropping all those numbers, or those huge amount of numbers, into kind of classes or groups of numbers. All right. So example 1, we already kind of talked about a little bit. I'm noticing right away. Remember the years. So I'm thinking, man, line graphs can be the best option. Sure enough, they say double line graph. Of course, we do have company A and company B. So the double line is kind of the idea of you'd have company A as one of the lines going, and then company B, might be the same as A at times. It might jump up, go where company A jumps down at different points, but you kind of see both lines as they go across the graph. So that would be a double line graph, and that would be once again most appropriate because you're given the time in years to compare the profits of the two companies over time. They do say a bar graph would also work, but because of time involved, once again, line graph's going to be your go-to on this one. And then they just go on to tell you why circle graph and histogram are not great options. So we'll skip that here for now. But example two. Example two would be favorite classes here, and then number of students. So you really have two options at this point. A bar graph, I'm thinking right away, would be a pretty easy option. So sure enough, they say a bar graph here. So a bar graph works because you have the classes as categories and the frequency, right? The number who said each class. 25 said math, 15 said science, right? So right there, you can set up your bars. 25 for math, 15 for science, 8 for social studies, so on and so forth. You could also, it's a little bit more work, but you could also set up a circle graph, right? You'd have to basically add up the 25 to 15, that's 40, 48, what's 60? There's sort of 60 total students. You have to add up those numbers to get 60 and say, all right, well, 25 of the 60, figure out what percent that is, make your circle and have that percentage be the part that says math. And okay, 15 out of 60, that's 1/4 or 25% science. Make a part of the pie there, the circle graph that says 25% science. So you could do that, right? A circle graph works well because you could convert them into percents. Once again, the number of that said each subject versus the total number of students. All right, and then once again, they tell us why the other two aren't appropriate. Biggest thing here with line graph being is there's no time here anywhere. So we just literally can't say line graph, right? It has to have time, and there's no time here. Histogram, once again, there's not a large amount of numerical data. All right, speaking of large amounts of numerical data, example three, I'm noticing that right away. Look at this. I don't even know what we're looking at here. What the average number of days annually when cloud cover covers at most 30% of the sky during daylight hours. We've got all sorts of cities: Birmingham, Fort Smith, San Diego, Grand Junction, right? All sorts of things on here. Gosh, this is a lot of data here. Pretty excited. If you see on there right above Indianapolis, Peoria is on there. That's actually I assume that's Peoria, Illinois. I think that's my hometown. Could be Peoria, Arizona as well. But anyways, but huge amounts of numerical data, right? So histogram, clear choice. Most appropriate graph because we have a large amount of data. We could break this data down into equally sized intervals or classes and find frequency or the number of cities that have numbers that would fit in a certain class, right? So between 100 and 110. How many of the cities fit in that class? All right, between 111 and 120. All right, how many fit in that class, kind of thing. So, in fact, they've done that kind of for us, right? So they make a little example of a frequency table that you could use to make that histogram. So they've broken them into probably a little bit better than what I just did here, classes of about 25 each or so. And then you can see, all right, 8 of the cities fell within that first class, 15 of the cities fell within the second interval or the second class. And then from there, you could make a histogram. And it look a little bit like a bar graph, but once again, it's a histogram because we've broken the data into equally sized classes. And so that's kind of a giveaway. Histograms can be the go-to. So much data, right? So, all right, that's kind of just a quick overview of what we're doing here on Monday. As always, if you have questions, email me or hop on Zoom. And yeah, good luck with it.